Today we have domain of an expression. So there's three examples, right? Number one is x squared minus 7 over x minus 4. So in order to find the domain is pretty much every x value that makes sense here. So in order to find the domain of this, we're going to set the denominator, which is x minus 4. X minus 4 is going to be equal to 0. Because we can't divide that by 0, so we need to find what number here is going to give us 0, and that is a number that won't be undefined, right? So this, if we solve, we're going to get x equals to positive 4. Because if we plug a positive 4 into the expression right here in the denominator, it's going to give us a 0, and that is undefined. So x is equal to 4. So we can write the domain as x such that x cannot equal to 4. Right, so this x cannot equal to 4 because we can't really divide by 0 here. We can also write the domain as negative infinity to 4 union 4 to positive infinity, right? Because we can put any number in the negative side, any real number in the negative side in here, and it will make sense. But we can't put a 4 because it won't make sense. Same in the positive infinity. We can put any number in the positive infinity, and it will make sense. So that is our domain written in both notations. So yeah. Now let's go on to number 2. X plus 7. So when we have a root, a square root in this case, we can have the square root of 0, right? But we cannot have the square root of negative 1 in terms of real numbers. So we want this to be greater than or equal to 0. So we set this as x plus 7 is greater than or equal to 0. And now we solve. This will give us x is greater than or equal to negative 7, right? X is greater than or equal to negative 7. Because if we plug in a negative 7 here, we got a 0, and we can have that. But if we get anything less than a negative 7, this will be undefined. So again, our domain, we can write it as x such that x is greater than or equal to negative 7. And our pretty much, oops, sorry about that. We need a bracket, negative 7 to infinity. We put a bracket because a negative 7 is included in our inequality here. It is included, so we can put a negative 7 here, but we can't go below that. So we put a bracket there, negative 7, comma, infinity, because it goes all the way to infinity. In infinity, we never have a bracket. We always have parentheses. Same right here. So negative 7, bracket negative 7 to infinity. We put that when we have a equal sign at the bottom of the inequality. All right? So let's go on to number 3. Which is x squared plus 2 divided by x squared plus 4x plus 3. We can obviously set the denominator x squared plus 4x plus 3 equal to 0. And then we just factor this out to get our, basically our 0. So I'm not going to go into factoring in this one, but if you pretty much fully factor this out, we're going to get x plus 1 times x plus 3, right? X plus 1 times x plus 3, because if you multiply these two terms together, you will get this. So now that we have x plus 1, we set it equal to 0, and x plus 3 is equal to 0, right? So if we solve, we get x is equal to -1 and x is equal to -3. So again, we put our the domain as x such that x cannot equal to -1 and -3. So these x here cannot equal to -1 or -3 because that will pretty much make this equation equal to 0, and we cannot divide by 0 here. We cannot divide by 0. So that is going to be our domain. And in our little the interval notation, we have negative infinity, because negative infinity to -3, right? -3 parentheses union -3 to -1 union -1 to positive infinity. So we cannot plug in these two numbers, but we can plug in any other number because that will make sense in this this example right here. So that's going to be our domain in interval notation. Negative infinity, anything negative infinity makes sense, but if we put in a -3, that won't really make sense. And these two don't make sense. And anything to the positive side of infinity, it will make sense if you put it into the expression. So yeah, that's how you do these three examples of the domain of an expression, and yeah, that's it.